Welcome back, everyone. Our second presenter is Dr. Mickey Taylor. He received his PhD in environmental toxicology from Clemson University in '98. His experience includes 20 years as a greenhouse, nursery, landscape, and garden center owner, head grower, and pesticide applicator for his 55,000 square feet greenhouse operation. After 1998, his research explored the efficacy of constructed wetlands for remediating nutrients and pesticides from commercial nursery operations. In 2006, he became the director of research for a small biotechnology startup company in UGA's Biobusiness Center, working to commercialize a biopesticide booster product. In 2011, he became a senior agricultural advisor in USDA's Foreign Agricultural Services Civilian Response Corps, where he spent one tour in Afghanistan running a demonstration farm and working with Bagram detention facilities, agriculture teachers, to re-educate Taliban detainees that were deemed low risk. 4 years ago, he became the coordinator for UGA's pesticide safety education program and has been working since then to improve and modernize the program. Mickey, the floor is yours.
Thank you, Bodhi. Good morning, everyone. I'm going to go over some information about how pesticides move in the environment and some of the effects that they can cause in the environment. Well, let's see if I can get this going forward. Some of the learning objectives I want you to take away from this is to understand how pesticides move in several different ways on the air, in the water, on other objects, and how to adjust your methods to minimize the environmental impacts while you maximize your effectiveness and keep your costs down. I also want you to understand that there are environmental consequences for using pesticides, and I want you to learn some of the effects that they have on sensitive sites and non-target organisms, other plants, our pollinators, endangered species, and the like. You should always think when you're getting ready to use a pesticide that there is some risk involved to the environment, not to mention to you, from using that pesticide and applying it. In this case, you can see there could be effects both in the stream and on some of the wildlife near this guy that's applying a pesticide into the wind. Not exactly a good idea. First, let's define what the environment is. Basically, it's the entire planet around us. Everything on this planet is interconnected. Things that we do here can have an effect throughout the world. We found that out using chlorinated hydrocarbon pesticides back in the 40s and 50s and 60s. When I was growing up, you could find turkey buzzards everywhere, just about. Shortly after I went to college, it started to get to be very difficult to find turkey buzzards. Finally, after they banned DDT and 20 or 30 years passed, we're starting to see more and more of them. They're finding the same thing in other countries such as India. They had not banned some of the pesticides there that caused problems with raptors, and they just about lost both of the species they have of buzzard that clean up the environment. You should always be sensitive about the beneficial organisms out there that are helping you do your job. The people around you, your families, the water that we drink. There's a lot of public concern about how pesticides affect the environment. There's a lot of misinformation out there, and part of your job is to help improve that state by putting good information out there. Now, several of the characteristics of pesticides affect its pollution potential. One of those is solubility, which is simply how easily it dissolves into water. So that affects how likely it is to move into water systems. Soluble pesticides are more likely to move off with surface water or down through the soil if there's a rain event afterwards into groundwater and cause problems there. Another of the characteristics is the adsorption ability of a pesticide. This is how tightly it gets attached or bound to soil particles. If it's held very tightly by soil particles, it's unlikely to move out of the soil and into water systems. Higher adsorption occurs when you have oil-soluble pesticides. Those water-soluble pesticides are not going to be bound as tightly to soil particles. Clay and organic matter increase the binding because they have more positive and negative charge sites that can help hold that pesticide to itself. It also decreases the potential of a pesticide to move down through the soil, so it stays there in the soil for longer periods of time without moving. Another characteristic is a pesticide's persistence. This is how quickly or rapidly it decomposes, how long it remains active in the environment after you apply it. If it remains active for a long period of time, you get continued pest control, but you also have the potential for more problems from that pesticide being active in the environment. Sometimes if you apply a persistent pesticide that stays around for the next time that a crop is planted on that particular field, you can end up with illegal residues on that rotational crop. And this can cause a problem for farmers that are trying to sell that particular crop. It can also harm sensitive plants and animals on that particular site. Finally, the last of the characteristics I want to talk about is how volatile a pesticide is. This is how easily it turns into a gas or vapor. Obviously, herbicides are going to be of the greatest concern about this. We've discovered over the last couple of years with the use of 2,4-D and dicamba products on cotton and soybean, especially in the Midwest. It hasn't been a problem here in Georgia because we did a good job of educating people about volatility, but out in the Midwest, they've even had people killed in arguments over the damage that these herbicides do to neighboring crops that aren't protected from them by their genetics. And now volatility increases with increasing temperature. Increased wind speeds will take it into the atmosphere a little bit easier, and lower humidity will also increase the volatility. So if you're applying in cooler temperatures, that's why some herbicides say never apply it above 85 degrees Fahrenheit or above wind speeds of 10 miles an hour. And if you apply it when the humidity is a little bit higher, it's less likely to volatilize and move off your target site. Let's talk a few minutes about how pesticides are degraded. The primary way that pesticides get degraded in the environment is through microbial action. These microbes actually use the pesticide as a food source. It's actually an energy source. They break these bonds apart and use the excess energy stored in those bonds to help them grow and reproduce and make more bacteria or microorganisms that will break down more pesticide. There are certain conditions that increase the activity of microorganisms in the soil. You can probably guess what most of them are. Warm soil temperatures, good moisture levels in the soil, good fertility so that there's additional food sources there for them, and certain elements of food such as nitrogen, potassium, phosphorus, a favorable pH level if it's not too acid or too basic a soil, Adsorption of the pesticide onto the soil keeps it in place so that the microbes have a longer period of time that they can actually work on that pesticide and degrade more and more of it. And oxygen, soil aeration, helps improve the degradation from microbes. One of the non-chemical ways or non-living ways that pesticides are degraded is by chemical degradation. And this is a process we call hydrolysis. Typically occurs with a high pH level, and it's a reaction in water that helps degrade the pesticide. Certain soil properties and conditions affect how fast this occurs and the type of chemical reactions. It's not very important, but in some circumstances where you have high pH, it can be a moderate contributor to the degradation of pesticides. Now, the next way that pesticides are degraded is by photodegradation, and we take advantage of this when we clean our personal protective equipment. If you hang your washed personal protective equipment out in the sun's high energy light packets, we call them ultraviolet light in either UVA or UVB energy levels, will actually destroy the pesticide, break it down so that it is goes into some of the parts that it's made up from. Now, when the pesticide's incorporated in the soil, obviously the sunlight can't reach it. Those UVA and UVB waves don't go very deeply into the soil. They're stopped very quickly at the soil surface. So by incorporating some of the pesticides into the soil, we let them work longer. Bacillus thuringiensis, BT, is one of the products that is affected by sunlight. It can be broken down in just a few hours in very bright light. But if it's protected by the plant or by being under the foliage a little bit, it will last a lot longer out there in the sunlight. There are a number of factors that affect pesticide movement. We've just talked about the chemical characteristics, but your user practices also affect how easily pesticides move in the environment. The surface characteristics of your application site, whether it's a steep or a flat site, also affect whether or not the pesticide is going to move off site easily. Whether or not it's vegetated also has an effect on it. The soil type, sandy soils, it's more likely to move down through the soil particles and get to groundwater. Clay soils, it's not going to move as rapidly. That keeps the water from penetrating the soil quite a bit, so it stays there longer and gets affected by microorganisms, the sunlight, and the potential for hydrolysis. And then how deep the water table is and how permeable the bedrock is affects how easily the pesticides get down into groundwater. Let's go over these a little more detail. Pesticide user practices can include how you store the pesticide, how you mix the pesticide, your loading practices, whether you have spills or leaks in with your equipment. Your actual application procedure will affect it. And then how you go about cleaning your equipment and cleaning up spills, how effective you are on that will affect how that pesticide gets into the environment and how much of it gets there. And then how you transport the pesticide and dispose of waste of the pesticide or dispose of the pesticide container itself once you empty it has an effect on how the pesticide gets into the environment. We talked about the solubility, the adsorption, the persistence, and the volatility before. On persistence, soil sterilants can leave illegal residues on the following crops that are planted in that particular soil, even years later, because some of them last a very long time. For volatility, if you get a non-selective herbicide that gets volatilized, such as the 2,4-D or dicamba, when it moves downwind and off that application site and contacts a sensitive plant, it can cause a lot of damage. The soybean and cotton are some of their seeds are produced now that they can tolerate those particular pesticides or herbicides, but the ones that don't have those genes incorporated can be damaged very easily by these non-selective herbicides moving off the target site. The characteristics of the surface of your target site need to be considered, whether it's grassed or bare, such as in this nursery area. You've got gravel there, you've got a plastic material that's covering the surface that will shed the water very easily. What the temperature is. Higher temperatures lead to more problems with the pesticide moving off site. The slope, the humidity, how clean it is. You see on this particular, on some of these plants, there's a lot of debris underneath of them. That's going to provide organic matter to tie up the pesticide and keep it from moving off when irrigation is applied. And then whether or not there's a rain event shortly after your application of a pesticide. How much sunlight is reaching the application site, whether or not there's air moving over that or through that application site, and the permeability of the soil there. You always want to identify your vulnerable soil types, such as sandy soils. You get a lot more infiltration there. The well-drained soils with not very much clay or silt are vulnerable. Clay soils are less likely to be vulnerable to infiltration, but they're more likely to generate runoff from themselves. And then soils that are easily saturated are going to lead to more runoff as well. You want to handle pesticides to ensure that the pesticide itself or waste don't contaminate the soil, because it's going to be there a while and it can either move off site or down into the soil and cause problems once it reaches the water table. Let's define a few of those terms there. The water table is just the upper layer of water saturated zones. So if you were to dig down into the soil, once you start getting water building up in the bottom of that hole, that's when you've reached the water table. Recharge is the actual rain or irrigation material that's starting to move down through the soil and into the water table. An aquifer is a zone of rock, sand, or gravel that's 100% saturated with water, and that's where a lot of our wells provide drinking water to us, because that's where the wells go down to, is into an aquifer. Sinkholes typically form in limestone areas, and that can move a lot of water through what we would call caves, but they're water-filled caves, and move the pesticide that gets in there quite quickly. Let's look at some of the ways that pesticides move in the environment. They move on the air as spray drift, vapor, or dust particles. We'll get to how they move by water as surface runoff or infiltration or movement through the soil in a few minutes. And finally, we'll look at how other objects can move pesticides off your target site, either as residues on plants and animals, or on your equipment, your clothing, the products that you harvest from the site, and that sort of thing. First, we'll look at spray drift. You can see in the top right picture This guy's applying a pesticide to a forestry crop using an air blast sprayer, and he probably should have turned off a couple of nozzles at the top of his air blast sprayer because he's spraying a lot of pesticide just about straight up into the air and not contacting the trees. So that pesticide is doing no good for controlling the pests that he's trying to control, but it is up in the air now and can move off site with any air movement and cause problems downwind. It's really defined as any airborne pesticide droplets that move off your target site. The label will have management options that you should follow. There may be mandatory no spray buffer zones at the edge of a application site. It may specify specific droplet size requirements. As I mentioned before, there may be wind speed restrictions. Do not apply if the wind speed is above 10 miles an hour or above 15 miles an hour. Almost all pesticides will restrict it above 15. You just do not apply a pesticide when the wind speed is that high. It may have you apply so much pesticide in a certain volume of diluent, typically water. Aerial applications may have certain restrictions on them, and there may be warnings for sensitive crops or sensitive sites to keep you from applying the pesticide there so that it doesn't cause a problem. It's typically influenced by a number of different things. Outdoors, it's the wind. Indoors, it may be air currents generated by ventilation systems. Spray drift can be influenced by how big the particle sizes are, how big those droplets are, the height and the direction of the release. You can see in this picture, there's an awful lot of release up into the air where it's not contacting these peach trees. All that's going to drift off site in all likelihood. And then whether or not the pesticide tends to form vapors. If it forms vapors, it's more likely to move off site. How do you minimize spray drift? Well, you look at some of the variables that influence drift. These may be the type of nozzle you're using, the nozzle size that you're using, the pressure that you have in your spray equipment, and then how fast you're driving that sprayer over the application site. And then, as we saw in those pictures, the distance from the sprayer to the target and your release direction. There are also drift adjuvants that you can use with your spray equipment to reduce how easily they drift off, the droplets drift off site. Typically, it'll make the droplets a little bit larger so they have less likelihood of drifting off site. You also need to assess the weather, whether or not the wind's going to pick up while you're making that application, whether or not there's a rain event coming in shortly after you complete your application. That may increase the likelihood of it moving off site. So you have to look at all these variables and make a decision whether or not to apply the pesticide. Some of the decisions you'll make, you can see from this picture, they can have severe consequences. This particular individual applied a herbicide that drifted. The wind was apparently blowing at this hedge. And as I remember, it cost him $10,000 to replace this hedge. That was a very expensive decision on his part and not a correct decision. You need to assess what sensitive sites are near your application site, whether or not you need a no spray buffer zone, looking at the label instructions, what that instructs you to do, assessing the weather conditions, whether or not you've got very stable air, that may not be a time to apply a pesticide. The wind direction and speed you need to watch out for. You need to set up your equipment with the appropriate boom height, the appropriate nozzles, and the appropriate pressure to minimize how likely you are to get spray drift. And then make that final decision. Do I spray today or do I not spray today? That's going to be very valuable question to answer for you if you make, especially if you make the wrong decision. You want to set up your equipment properly. If you want to use a nozzle and pressure to give you an appropriate droplet size, a lot of times the label will tell you specific droplet sizes to use. Medium and coarse droplet sizes are better than smaller ones. Smaller ones tend to drift more. Smaller orifices give you smaller droplets and give you more drift. Lower pressures, except with certain nozzles like Venturi nozzles, can lower the likelihood that you're going to get spray drift. The spray pressure is something that you need to watch out for. To double your output, you've got to increase the pressure fourfold. That's going to give you much smaller droplet sizes and much more likelihood of having that pesticide drift off your target site. The droplet size, the smaller the droplet, the more likely it is to drift off site. You can see from the small one here to the large one, it goes from an 8 foot in 3 mile an hour wind drift to over 1,000 feet. That's a lot of difference. And the larger the spray droplet size, the less distance that droplet's going to drift before it falls, is acted on by gravity and falls out of the air and can no longer drift. Weather conditions affect it as well. You need to evaluate what's downwind. So you need enough wind to determine a direction. So that's typically more than 3 miles an hour, 3 to 7 miles an hour. You can usually figure out the actual direction that it's likely to move and evaluate what's downwind. Very slow speeds, it could move a long distance because it may stay in the air a very long time. If it's more than 7 miles an hour, you're probably going to have some material moving off site, and you're going to have to evaluate whether that's too much. The height of your boom above your target site is going to affect how far that spray drift goes. So you want to reduce the distance those droplets have to fall before they hit the target and no longer can drift off the target site. Viscosity is another thing that you can use. More viscous sprays batch don't drift as much. That's why invert emulsions are so good for rights-of-way control, weed control. They don't drift very far at all. Water-based formulations are affected by evaporation, so higher temperatures, lower humidities, you get smaller and smaller particles, which means they can drift more and more. Drift-reducing adjuvants are more and more common these days, and they can be used to increase the number of larger droplets and reduce your spray drift. And finally, looking at the weather. We already looked at this slide before, but there's another thing that is involved here, what's called a temperature inversion. This is when the air is very stable with just minor airflow. The air at the ground has cooled. Typically, this forms in the late afternoon, early evening, so the heavier air drops to the ground. The warm air rises above it, and it acts like a blanket. The warm air just holds that cool air at the surface, and you get very stagnant air, and this is called a temperature inversion. You can get long distance drift because it's a very long time, almost overnight into the next morning, before you start to get a mixing of those two air layers. so that you no longer have gradual drift. Temperature inversions can occur at any time. It usually develops at dusk. It may continue throughout the night. It'll break up when the ground warms in the morning and you start getting mixing there. It may appear like the ideal time to spray a pesticide, but it's probably one of the worst times to spray a pesticide because you have no idea which way, what direction it's likely to drift. And if you're using a herbicide, that can be a very bad thing. Let's look at vapor drift. Certain products volatilize and move with the airflow off the target site during warm weather. As I said, most of the labels will have something like 85 degrees as the maximum temperature that you can apply the pesticide. Once it gets above that, you have to stop applying that particular pesticide. Typically, it's going to be herbicides, and the really bad ones are the non-selective ones that will basically kill any or harm any green plant. That's not genetically protected from that particular herbicide. You want to read that label carefully for what the cutoff temperatures are and any other precautions that the label might specify. Now with the 2,4-D and dicamba, there are low volatile formulations out there that you can use to reduce the likelihood of volatility. That does not mean volatility is zero. Even some of the low volatile formulations have had problems in the Midwest causing damage downwind because people did not follow all the instructions that they were required to follow. So you have to be very careful with those types of products. Let's look at particle drift next. This typically occurs with dust or granular applications. Even granular applications will have some dust in there. Certain pesticides will attach to soil particles and remain active. And when the wind picks up, it can blow it off the target site. You need to read the label to see if you need to incorporate that pesticide into the soil so it's less likely to be at the surface and get wind blown into a non-target area. You have certain responsibilities that you're required to follow. It's just your legal responsibility for damages anytime your pesticide moves off target and causes damage off the target site. You need to assess the vulnerability of those nearby sites that are downwind from you that might be affected by your application. You need to evaluate weather conditions to see whether that's going to become more adverse as you apply the pesticide and make a decision accordingly. You also have to adjust your application equipment to minimize the likelihood of off-target movement of your pesticide by drift on the air. And you should develop a good drift management program where your people always read the label, follow the instructions on there, check the weather, check all these various things I've talked about, your equipment, that sort of thing, and try to minimize the likelihood of drift off site. Now let's go look at pesticide movement in water. It can either move as surface runoff or down through the soil through leaching and infiltration. Surface water is basically any water that's on the surface of our planet. Lakes, rivers, oceans, even mud puddles are considered surface water. Recharge is the water that goes down through the soil from rain, melting snow, or from our irrigation practices, and it goes into the water table and eventually into aquifers to recharge them. As I said earlier, the water table is the upper level of the water saturated zone. The aquifers are permeable zones of rock, sand, gravel, or limestone that are saturated with water. And typically our wells are dug down to those or drilled down to those aquifers, and they provide a lot of the drinking water, especially around Georgia. Surface runoff is basically what it sounds like. You can see it in the upper right-hand picture here. We get a heavy rain or a heavy irrigation event, a lot of the water is going to run off on the surface. If it contacts something, a surface that has a pesticide on it, a pesticide residue, it can wash that residue off the surface and can then move it off site. There are two types of pollution that can result from this. Point source pollution is where you can identify the exact point that's providing that source of pollution. Typically, it's going to be a pipe, a ditch, your rinse pad, something like that. The other type is a non-point source where it originates from a broad area. Point source arises from something that's very identifiable. Spills and leaks into sewers from mix and load sites or from wash sites are obvious point source pollution. One that's not quite so obvious would be back-siphoning when you're filling your sprayer or during chemigation. If you don't have the proper anti-siphon device installed, or you get that hose down into the liquid mixture of pesticide and water and the power goes out, the pesticide mixture can be sucked back through that hose and get into a water system. Improper handling and disposal near water sources can also be a point source of pollution. As I said, non-point source is a broad area. Typically, it's going to be from a field, say a golf course, fairway or a green, something like that, or from a lawn for the turf and ornamental people. It's a broad source and you can't identify exactly where that pesticide is coming from. However, it's commonly blamed for a lot of contaminated surface and groundwater. Just because no one can identify where that pesticide came from, they're going to blame it on a non-point source. And typically that's going to be your ornamental landscape people, your farmers, those types of people, because they're easily blamed for it. The movement of water from runoff, the runoff quantity depends on a number of things. How moist the soil is. Drier soil, as long as it's not too dry, will absorb a lot of rainfall before it starts allowing runoff to occur. The amount and timing of your irrigation or rainfall after you apply a pesticide can have an effect on it. Your pesticide chemical characteristics that we talked about, whether it's adsorbed to the soil or not, whether it's water soluble or not, will have an effect. The grade or slope of the area, very steep slopes, it's going to run off a little bit faster. The texture of the soil and whether or not you've got vegetation there. The clay soils do not run off more easily than a sandy soil. Vegetated sites don't run off as easily as bare ground does. How do you minimize runoff? Well, you use that recommended nozzle size and the pressure so that you don't apply too much product to a particular area. You keep your applications close to the target site. You time those applications to avoid heavy rainfall events. And then you delay follow-up irrigation events until the sprays have dried or the dusts have settled. Leaching or infiltration is another way that pesticides move in water. Basically, it's just movement of the pesticide by water down through the soil. It can either move horizontally, be pulled into roots nearby, or it can go vertically down to groundwater. Chemical characteristics that should raise your concern about in leaching or infiltration are highly soluble pesticides, ones that have a low adsorption rate, and pesticides that are highly persistent. It also depends on the geology, how permeable that soil is, that soil texture and structure. As I said, sandy soils, you get fast percolation down through the sandy soils. There aren't many binding sites there, so the pesticide is likely to move very quickly. Silt, clay, or organic matter slows the percolation up. There are a lot of binding sites there that can hold the pesticide for longer if it's not a highly water-soluble pesticide. The depth to the groundwater. A shallow water table poses more of a concern than a deep water table. That's more of a concern down on the coast, but even up here, we probably have areas where the water table is fairly close to the surface. And then the amount and timing of your irrigation or a rainfall event. You can minimize leaching by properly selecting the pesticide and the formulation to get one that's not as water soluble, that will be adsorbed to the soil particles and held there until it's degraded. You can limit your watering after your application to reduce soil saturation. You can limit it beforehand to have semi-dry soils so that it takes more rainfall to get that soil completely saturated so that you get runoff from it. You can recognize highly permeable soil types and plan accordingly. You can increase the soil organic matter, incorporate some organic matter into the soil so that any pesticides you apply get tied up longer, held up and not allowed to go down through the soil as quickly. Even on sandy soils, this will help reduce how much pesticide gets down to the water table. And then using the minimum feasible application volume of the pesticide that's allowed on the label will reduce how much of the material is there that can end up running off. Using integrated pest management or IPM is another way of minimizing the leaching. Using only the pesticides you need when you need to use them to control a pest that you can't control in any other way. IPM is a great way to reduce your costs, especially of your pesticides and your labor costs of applying pesticides by taking advantage of pest management techniques, either biological control or cultural control, some of these other techniques that will limit how much pesticide you have to apply to the site to control that particular pest. You need to consider the depth to the water table. A very shallow water table, you may want to limit how many times you apply a pesticide there. You want to consider the site characteristics. What's the texture of the soil? How permeable is it? How much organic matter is present? Whether or not you've got silt and clay particles there to help tie up the pesticide. You also want to select your pesticide carefully. Is it one that's susceptible to leaching? If it's not susceptible to leaching, you're in a better position to use that particular pesticide. If it's a highly leachable pesticide, you may want to think about it, especially if your water table is very shallow. Following the label directions carefully, using the correct rates proper mix and load practices, proper disposal methods, cleaning up any spills that you might have will all reduce the likelihood that you're going to get leaching of that particular pesticide. Identifying vulnerable areas where you have sandy soils, wells, streams, ponds, sinkholes, shallow groundwater, all of those can help you manage how much pesticide might end up in the water table. Handling the pesticides to ensure that the pesticide or waste don't contaminate the soil is your responsibility. If you have a product that poses some concern, you need to try to manage that, either making sure that the soil's a little bit dry and not going to run off if you get an irrigation, have to do an irrigation event shortly after applying it, using the cooler soil temperatures to reduce how quickly, to not get the pesticide down in the soil, because the microbes need the warmer temperatures to work better. Watching out for shallow groundwater, avoiding those soluble pesticides, avoiding that sandy soil if you can. If you don't have much concern for leaching, your selection of a product is not that big a deal at that point, because it's less likely that they're going to get there. You want to follow the labeled directions to keep pesticides out of groundwater. This is another reason to calibrate accurately. Another good reason to calibrate accurately, besides the fact that the law requires it, is that you save money by applying only the amount of pesticide that you need to apply to control that particular pest. You also want to check your equipment to make sure you don't have anything leaking. You want to measure accurately. If you're measuring a liquid pesticide, you want something narrow and tall with a lot of gradations in it, so that you can accurately measure how much pesticide you're putting in that spray tank. You don't want to over apply the pesticide. Number one, it's illegal to go over the maximum label rate. Number two, you're wasting money because it's not going to give you any better control of the pest. And number three, you're going to have a problem with it getting into groundwater, and then you're going to hear about it quite vociferously. Another way to keep pesticides out of the groundwater is to use that air gap. You can see on the right-hand side where the hose is at the top, you've got a big air gap before you get to the pesticide water mixture. You can also use an anti-siphon device or a check valve, which you see in the center of the picture there. They will prevent that pesticide from being sucked back into the well. On the left-hand side is the wrong way of doing it, having that hose down into the spray mixture, not having a check valve or back siphon device on that spray wellhead where you're getting your water from. Those can lead to problems that you will have to deal with. Choosing the proper mix location. It should not be near water or drains. You should also consider using a mix and load pad, especially if you're doing mixing and loading in the same place many times. There are available portable pads that you can mix and load your equipment on. They can be moved from one site to another. They will prevent that pesticide, if you spill any or have a leak from your equipment, from running off and getting into surface water or into groundwater. You need to consider those. You need to design your mix and load pad to help you control any spills or leaks. In this case, you've got a drain in the center of the mix and load pad. It's of impervious concrete material. If in that drain, you would have a place where you can go in there and recover the material. If you keep that mix and load pad clean, you may be able to reuse what you spill or leak and put it back into your spray tank or use it again in the future. You always want to clean up spills when they happen, avoid them if at all possible. You want to dispose of waste properly. That means triple rinsing your container, putting that rinse water back into your spray tank, and it then becomes gets applied to your target site so that you don't have any rinse water to deal with after you get through with your application. You want to store your pesticides away from water sources. You don't want them right next to a wellhead or next to a surface water, especially a stream or wetland that might have some non-target organisms living in it. Some of the things you do not want to do is use more pesticide than the labeling directs. That is illegal and will get you a significant fine if you're caught at it. You want to use application methods that don't present special risks. Chemigation has to be on the label to be able to use it, but you need to realize that chemigation is a very hazardous way of applying pesticides. Sometimes it's the best way, but not always. You want to allow pesticides, you do not want to allow pesticides to back-siphon into your water source. That can become a nightmare trying to clean up. Some of the things you want to do is locate your pesticide storage facility, your mix and load site, your equipment cleaning site, at least 100 feet from direct links to groundwater, such as wellheads, and 200 feet from surface water. That is our recommendation. Both my office and the Georgia Department of Ag. In Georgia, there is no required distance from a wellhead or from a surface water for these storage facilities, mixing and loading sites, or cleaning sites. But we highly recommend that you use this guideline to reduce the likelihood of your having an issue later on. You want to dispose of unused pesticides, the pesticide containers, and clean your equipment and the container wastewater correctly. There are instructions on the label of how to do that. Now let's move to how pesticides move on other objects. They can be as either residues on plants and animals. You see in the lower right corner here a picture of a philodendron from a neighboring state, shall we say, that came up with an awful lot of pesticide residue on it. I was in the business for 20 years. I got a lot of plants like this shipped up to me. You have to clean those before you can sell them to your customers. And that becomes a big draw on labor. Let's see, pesticides can actually move on you, your clothing, your shoes, your machinery and equipment, even your turf and ornamental guys. When you cut grass after or do some pruning after applying a pesticide, those leaves and grass clippings may blow off site, or you may rake them up and take them off site. Where you deposit them is where that pesticide is going to end up going to. The pesticide residues can also be on treated products taken off site. Container plants, as I showed the picture, mulch and pine straw. Let's take a look at this picture. This guy applied a herbicide right at the base of this tree and then walked away from it. Can you guess what he did wrong? Quite likely he was standing in the area he was spraying and probably spraying his own feet. Or if he was picking them up and putting them down, he got a lot of pesticide residue or herbicide residue in this case on his feet. And you can see exactly where he walked away from the job. And you can believe the customer is going to see that too. You also need to think about protecting sensitive areas. These can be parks, recreation areas, playgrounds. Those are the obvious ones. But apiaries, wildlife habitats, people's yards, people's gardens, even crop fields can be sensitive sites. Where endangered species live are sensitive sites, basically by definitions, and wetlands, biodiversity, nurseries, which are part of wetlands, streams, rivers, hillsides, refuges for animals and plants are also sensitive sites. We all want to try to protect non-target organisms. One of the major ones that we don't think about are plants can be non-target organisms. We'll see a picture of that in just a minute, how that can be a problem. Our bees and other pollinators we have to protect. The beneficial insects are out there helping you, so you definitely want to protect them. They're reducing how much pesticide you have to apply and expose yourself to. Fish and other wildlife, humans, threatened and endangered species are all non-target organisms that we have to watch out for. Herbicides are the primary cause of non-target plant injury, and this is often through phytotoxicity. But if you're using a herbicide that's a non-specific type, a non-selective one, you can get plant injury from the herbicide itself. Even insecticides and fungicides, if they've got some of the organic solvents in them, can cause this phytotoxicity, and it's very noticeable on plants off the target site. The symptoms of pesticide injury are very similar to other problems. You want to read that label and avoid drifting off the target site. You don't want to apply toxic pesticides if there are blooming plants in an area. The best thing to do would be to mow this verge to where you're going to apply a pesticide to get rid of those blooming plants so that bees and other pollinators aren't coming in while you're applying the pesticide. You want to reduce the drift off the site. You would apply that pesticide, make your application either early in the morning or late in the evening when bees and other pollinators aren't foraging. That's what mosquito control operators do. They're applying late in the evening or early in the morning when those pollinators aren't active. And so they're controlling just the mosquitoes with those fogs because everything else has gone to sleep for the night. You want to select pesticides that are least harmful to bees, low hazard formulations, avoiding microencapsulated formulations. These are very tiny particles, resin balls that have raw pesticide inside them. They're about the same size as pollen, so the bees tend to pick them up and carry them back to the colony. When they chew on them, you've got raw pesticide being released into the colony, which can cause a lot of bee death. Check your label to see how toxic it is to bees. You may actually have to spot treat an area. Also, cooperate with beekeepers, try to educate them. Most of them think pesticides are the worst thing out there, but if you educate them carefully with what you're doing and how you're using low toxic formulations, you're likely to get them on your side and they won't complain as completely. If you see a honey bee in a red triangle, or red diamond, I should say, that is EPA's new bee advisory box. You need to read that very carefully. and follow the instructions on there. You want to recognize beneficial insects as helpmates. They're valuable allies in your pest management. Some of them are pretty ugly, as the one in the lower right. That's a ladybug in the larval stage. You want to select pesticides that are not as toxic to these helpmates out there. They're more selective against your target pest. Protecting fish is very important. Anyone that's been around a fish kill knows that everybody in the neighborhood is going to know you killed some fish within a few hours. Protecting birds and mammals, or something else that you can do. A lot of the granules or baits or treated seeds are attractive to birds and mammals, and you have to make sure that you don't get secondary poisoning of them or secondary poisoning of raptors and scavengers by killing these birds and mammals and getting them fed on by the raptors. And finally, protect threatened and endangered species. Endangered species are only on the brink of extinction. Threatened are likely to become endangered species. Habitat destruction is probably of at least as much concern as pesticides. The pesticide label will tell you to consult a county bulletin for special precautionary measures if you have a threatened or endangered species found in your area. And EPA has an excellent website that they just redone on endangered species. And that's the end of the presentation. And I guess we'll go back to Bodie and see if anybody has any questions.
Thank you, Mickey. We are almost out of time for the questions, but if the audience has a couple, we can entertain them. I haven't seen anything come in the chat box. Mickey, I guess you talked about everything. You covered all the aspects. It was so informative. I really enjoyed it. Thank you so much.
Well, thank you, Bodie, for inviting me. I try to cover all the different angles because I've been in the business and seen it from the business end.
And that's very important. That kind of experience could really give the 360 angle to the topic. All right, well, I guess we are done. Thank you to both of our speakers. Thank you for the audience for joining us today. Our next webinar is on March 13th, so we hope that you will join us on that date as well. And have a great January, have a great year. We'll see you on March 13th. Thank you very much, everyone.